name is Afolabi, and today we will continue with our study of probability. But we'll move our study of probability to a certain aspect, which is binomial probability. And in binomial probability, you actually see much question of binomial probability in your further mathematics than in your mathematics. But at times in your NECO mathematics, you might come across binomial probability. So it is very important that we take it out now. So binomial probability are those type of probabilities that have only two possible outcomes. There are only two things that could happen in the event. Just like your tossing of coin. You know, if you toss a coin, you only have two things that can happen. It's either you get head or you get tail. Those kind of probabilities that you only have two things that can happen. Okay? Or for example, if you have if you go for an election, it's either you win the election or you lose the election. Those kind of probabilities that you only have two possible events. They are binomial probabilities. Then in that kind of probability, you will do the probability more than, you take the events more than once. Just like you are tossing a coin like maybe 4 or 5 times. When you do the probability more than 2 times, then it becomes a binomial probability. So two things are necessary for binomial probability. Number one is that it must have two possible outcomes. Then the event must be done more than twice. Example of binomial probability, you have tossing of coin 4 times, okay, or 4 or more times, 4 or more times. Okay, you know, you have two possible outcomes for tossing of coin. It could be head or tail, and you are doing it more than once. So it is an example of binomial probability. Another example of binomial probability is production of defective factory materials of maybe after 1,000 productions. You know, factory materials, you only have 2 types of factory materials. You can have those ones that are defective and those ones that are not defective. Those are the 2 types of materials you can produce in the factory. But when you are producing 1,000, so you can see that the number of probability is more than 2. So when you have probabilities like this, then you are talking about binomial probability. What is the approach to binomial probability? We solve binomial probability by using the binomial expansion. The approach is that one, we take P as probability of success, probability of success. Okay, then we take Q as probability of failure. Okay, the success in this case could be probability of getting a head, and the failure could be the probability of getting a tail, that is the opposite of success. Okay, such that the total probability will be P plus Q raised to power n, where your n will be the number of times the event is done. So if you want to find the probability of tossing a particular coin, maybe and getting a head 4 times, when you toss the coin 4 times, that means the P will be the probability of getting the head, the Q will be the probability of getting the tail, then the n will be the number of times you carried out the event. Such that, remember, in your expansion, binomial expansion of P plus Q raised to power n. What's the binomial expansion of P plus Q raised to power n? That's P raised to power n, okay, plus what? P raised to power n plus n, P, Q, n P raised to power n minus 1, Q, plus n into n minus 1 over 2 into P raised to power n minus 2, P raised to power 2, Q raised to power 2, until when we get what? Q raised to power n. This is just binomial expansion that is obtained from probability, from combinations. Or you can say your P plus Q raised to power n is n combination 0, or P raised to power n, Q raised to power 0 plus n combination 1, P raised to power n minus 1, Q raised to power n plus Q raised to power 1 plus n combination 2, P raised to power n minus 2, Q raised to power 2, plus, and so on till you get to Q raised to power n. Now this expression here and this expression are the same. This one is combination. Remember, your n, r is what? N combination r. So what we have here and these expressions are the same. They are just a way of expanding the total probability, which is P plus Q raised to power n. So anytime you have a question like this question in tossing of a coin 4 times, what is the probability of obtaining A, 2 heads, B, all heads, C, 1 tail, D, at least 1 tail. Look at that probability. Number one, this probability is a binomial probability. Why? Because we have only 2 possible outcomes. It could either be head or tail. Then another thing is that we are doing the event how many times? We are doing it 4 times. So it is binomial. So if you want to solve this kind of question, you come with the total probability. Let's say the total probability. This is the total probability that could occur. Total probability will be P plus Q raised to power n. That is P plus Q raised to power 4. Why are we using 4? Because we are tossing the coin 4 times. So what's your P? P is probability of getting head. And when it comes to a single toss, what's the probability of getting head? 1 over 2, because we have head or tail. Probability of getting a tail is also what? Probability of getting a tail is also what? 1 over 2. Okay? So that means if you have P plus 4 plus Q raised to power 4, P plus Q raised to power 4, and you expand using this, what do you get? If you expand using this, what do you get? You get P raised to power 4 plus 6 plus 4P raised to power 3Q plus 6P squared Q squared plus 4PQ squared plus Q raised to power 4. So that's the expansion you get. So that means here you have what? You have 4 heads. You can see P raised to power 4. Here you have what? 3 head. 3 head plus 1 tail. Here you have what? You have 2 head plus 2 tail. Here you have what? You have 1 head and 3 tail. And here you have what? 4 tail. How am I knowing this? I'm knowing this from the power. The power of this shows that you're having 4 heads because P is the probability of getting head. The power of this means you're having 3 head and 1 tail. The power here means you're having 2 head and 2 tail. The power here means you're having 1 head, 3 tail. And here you're having all round head. This is the total outcome that you can get if you toss this coin 4 times. So if you want to know how many probability of having 2 heads, of course, from here, the probability of getting just 2 heads will be picked from this is probability of getting 2 heads. You can't just get 2 heads, you get 2 heads and 2 tails. So the first one here, probability of getting 2 heads, probability 2 heads will be 6. Of course, that's 6P squared, Q squared, and that is 6 into what's P? P is 1 over 2 raised to power 2 into Q, 1 over 2 raised to power 2. And what do you have there? This is 6 over 2 raised to power 4, that's 16. That's 3 over 8. That's probability of getting 2 heads. The second question there, probability of getting all heads. All heads. That's when you have P, all of them heads. That's P raised to power 4. That's P raised to power 4. All heads. That's 1 over 2 raised to power 4. And that's 1 over 16. You can see it's so easy once you are able to get the expansion. Then third one is probability of getting what? Probability of getting 1 tail. 1 tail. What's the probability of getting 1 tail there in the expansion? Where do we have a single tail? That's 4P raised to power 3 Q. 4P raised to power 3. 4P raised to power 3 Q. And that's 4 into what's P? 1 over 2 raised to power 3 into 1 over 2. And that's 4 over 16. And that's what? That's 1 over 4. And the last but not least there is probability of getting at least. Probability of getting at least what? At least 1 tail. Probability of getting at least 1 tail. And remember I told you probability of getting at least 1 of something is 1 minus probability none. 1 minus probability no tail. Don't forget, probability of getting at least 1 head is 1 minus probability no head. Probability of getting at least 1 tail is 1 minus probability no tail. So probability of getting at least 1 head will be 1 minus. Where is it that we have no tail at all? We have no tail. Here we have 1 tail, here we have 2 tail, here we have 3 tail, here we have all round tail. So here we have no tail, P raised to power 4. So that means it's 1 minus P raised to power 4, which is 1 over 2 raised to power 4. So I have 1 minus 1 over 16, and that's 15 over 16. This is the probability of getting at least 1 tail. So whenever you have probabilities where you have only 2 possible outcomes, and the event is carried out more than once, all you need to do is to get the 2 probabilities, the success and the failure. Once you get the 2 probabilities, then you find the binomial expansion with the number of times, and And with that, you can be able to know each of the probabilities. Remember, if you have any question with this video, you can always get back to us. Thank you.